Hey everybody, welcome to week number 7. This week we're going to be taking a look at a stroke care data set. So these patients are all patients that have had a history of stroke. And we're going to go through and run some statistical tests that will help us actually describe, this patient population if we were to use it in a, research study or something like that. Please, if I sniffle through this recording, I do apologize in advance. I am a little sick, but I will try and keep that to a minimum. Okay, so I have my version of the data set here. I will have approximately 33,000 cases in my data set. I believe you have about between 70 and 80,000 cases in your data set. So again, as always, just remember that the data and results that you'll see in my recording here is not the same answers that you will get when you do your analysis. All right, so a couple of questions do repeat from past weeks in this week's assignment. So I will still touch upon each of the 10 since this is probably one of the first assignments that we're actually going to start using a lot of what we've already learned and kind of combining it all together. So the first two questions are exactly the same. They are asking you to describe the distribution of the Charlson score and the Stroke Administrative Severity Index score, or the SASE score. So those are our two scores here at the end. There are two ways that we can describe or determine normalcy, or actually there's a couple ways that we can determine normalcy in SPSS. I'm going to show you two of them in this recording, and you can use whichever one you prefer. So the first way, and I will do this with the Charlson since it's question number 1, is to use the chart builder, which we have done in the past. So I will go to Graphs in Chart Builder and make sure that my bar is selected. And the first option here is a simple bar. So I will double click on that and then go down here to my Charlson score. And because I want to make a histogram, I'm going to bring my Charlson variable down here to my x-axis. And you'll see that SPSS will automatically switch that to a histogram for you. So from here, what else I usually like to do is to display the normal curve. This is just an easy way when the data is actually put out in the chart to see what a normal distribution would look like for the Charlson score here. There are no other options that we need to worry about in the chart appearance or the options area, so I'm just going to leave those as is and then just go ahead and click OK. So we can see here that my data is definitely skewed. I don't have a nice even bell across all of my Charlson variables. So I am going to say that my Charlson score is not normally distributed in my data. And the second way to determine normalcy is using something called skewness and kurtosis. Skewness and kurtosis are two different values that you can use. Let me pull open this here. So the first one, kurtosis, is a measure of the tailedness, or the weight of the tails. And the kurtosis is basically a value of how long the tail in the normal distribution is, or, like I mentioned, the weight of the tail. And then skewness is the measure of degree and direction of symmetry in the data. So if we had a perfectly normal distribution of data, we would have a skewness and a kurtosis of 0. And that would mean that over my middle value here, I would have the highest point of my bell. which I do not. Because again, we can see that a lot of my data is skewed over in the 0 to 4 area versus the rest of this tail here. So if I wanted to use or determine the skewness and kurtosis of a variable, I will choose Analyze and Descriptive Statistics, and then use my frequency here. And what I'm going to do is take my SASE variable and then make sure that I select my skewness and kurtosis here. And I'm also going to enable the mean, median, and mode. Because if you remember from past weeks, the mean, median, and mode value for perfectly normally distributed data would all be the same. And what we are looking for skewness and kurtosis from SPSS is a value of 0 or a value close to 0, which show normal distribution. If you were to use SAS or Stata or GraphPad or one of the other statistical tools, skewness and kurtosis can be calculated differently. So there are some statistical softwares that the skewness and kurtosis of normal data would be 1, but I've seen it most commonly that it's equal to 0. So I now, like I mentioned, enabled my skewness and kurtosis and my mean, median, and mode for my SASE variable. I'll click continue. You can display the frequency table, but as noted here by this ruler, the SASE variable is a continuous variable or a scale variable in my dataset. So I don't actually know off the top of my head what the range of these values actually is, or are, I should say. So I could end up with a giant frequency table or a fairly small frequency table. But in this case, because I'm just interested in skewness and kurtosis, you can go ahead and turn the frequency table off. We'll click OK. And I will look down here. I have a mean of 2.27, a median of 0, and a mode of 0. So I can already tell that it's most likely that my SASE score is not normally distributed. But we'll take a look at the skewness and kurtosis. I have a skewness of 2.5 and a kurtosis of 9.4. So neither of those values are even remotely close to 0. So I will again say that my SASE score or my SASE variable in my dataset is not normally distributed. Right. So question number 3. Question number 3 is a function that I don't believe that we have used yet in this class, and we will do, or we are going to use a function now called compare means. And the compare means is a very useful function in SPSS that will allow you to simply view the means of 2 or more values against a independent variable. So in my question here, I'm being asked, what is the mean patient age based on patient survival or death? So in this situation, my dependent variable is going to be age, and my independent variable is going to be death, or patient died. And in general, I am just concerned about the mean value here. Number of cases and standard deviation really isn't super important because we're not building a table 1. We're going to do that a little bit later in the semester. So like I mentioned, the only value we're really kind of concerned with is the mean. So I'm just going to go ahead and take these away just for cleanness sake here. All right. So again, I have my dependent list or my dependent variables, and that is the age, and my independent variable, which is the patient dying or surviving their hospitalization. And when I click OK, I now have a mean value of age for patients who did not die during their hospitalization of 72.12 years. And then I also have a mean age of the patients that died during their hospitalization of 73.06 years. All right. So moving on to question number 4. We are going to assume for the purposes of this question that the age variable is normally distributed. And it's asking, is there a mean age difference, or is the mean difference in age for patients who died during hospitalization and those who didn't statistically significant? So as the question mentioned, we are asked to assume that age is normally distributed in our situation. So what we will do in this situation, since it is normally distributed, we are going to run the independent samples t-test like we did last week in week 5 and week 6. So again, we'll go up to Analyze, Compare Means, and do the independent sample t-test. And my test variable, again, is going to be my age. And my grouping variable, or my independent variable, is going to be if the patient died or if they survived. And again, you have to remember to define the 2 groups that you want. So the patients who died and the patients who didn't die in my data set are represented by value 0 and a value of 1. So the other thing here in the options, the assignment mentions just to leave everything at a 95% confidence interval, which is the default for SPSS, so there are no changes that we need to make here. Excellent. So we'll click OK to run our independent sample t-test here. And again, we have our mean age, so we did not need to run the compare means analysis here because we would get it in our t-test, but I did ask you to do it this way just to introduce you to that statistical function in SPSS. So going down to our independent samples t-test, we are seeing that our Levene's test for equality variances is significant, so we will go ahead and assume that the variances are not, and look at the line here. So we are seeing a t-test for the equality of means of 0.031, which is less than our p-value of significance of 0.05, or our alpha value of 0.05. So we can say in this situation that the difference between the age difference between patients who died and the patients who did not die during their hospitalization is in fact a significantly different value. So moving right along here down to question number 5. If the Charlson score is a non-normally distributed continuous variable, is there a statistically significant difference in the mean Charlson score for patients with a history of acute ischemic stroke and those without? So we have already determined in our data set, or I should say my data set, that the values for the Charlson score are non-normally distributed. So I can go ahead and continue on my test here. Because I have a continuous variable, which is the Charlson score, and I am looking to compare it across a binary independent variable, which is the history of AIS. We we're going to run something called the Mann-Whitney-U nonparametric test. And in this situation, this is a test to compare if the difference in means of non-normally distributed continuous variables are in fact statistically significant or not. We saw last week on how SPSS can present some output in a little bit of a different fashion than this table here. And the output of the Mann-Whitney-U nonparametric test looks just about the same. So to access that test, we are going to go down to nonparametric testing and then choose the independent samples option. All right, so because I like to have all of the options available to me, I like to always choose customize analysis. I don't like SPSS to make decisions for me in this situation. So I'm going to go ahead and add in my test fields here. So I am interested in Charleston score. So I'm going to go ahead and move that over to my test field. And my grouping in this situation is going to be the history of acute ischemic stroke. Okay. And what I am going to do next is, instead of, like I mentioned, automatically choose tests based on the data, I do not want SPSS to do that. I only am interested in this situation in the Mann-Whitney-U. So you'll go ahead and choose Customize Tests and then enable the Mann-Whitney-U. The other options here are significance level and confidence interval. We already know. And then we already know that there are no missing variables, but if we wanted to include or exclude missing variables from our analysis, we have the choice to do so here. So again, just make sure that you choose the Customize Test and then enable the Mann-Whitney-U. We'll go ahead and click Run. This one usually takes a second or two to actually finish. And then we get our output here. So the output here, or the hypothesis testing summary, gives us one null hypothesis, which is the H0 or the HA, whichever you so choose. The distribution of Charleston Comorbidity Index score is the same across categories of history of acute ischemic stroke. So this is our null hypothesis, is saying that Charleston score is equal across, or the mean Charleston score or distribution of the Charleston score would be the same for patients that have had a acute ischemic stroke as well as patients that have not. And we can see here we have a significance value of 0.000, and SPSS is telling us to reject that null hypothesis. So we can say that the Mann-Whitney-U test has told us that the distribution of Charleston score is not the same across patients with history of acute ischemic stroke. So that there is a significant difference in Charleston score, mean Charleston score, for patients who have had an AIS and for patients who have not. So moving on to our next question, if the total charge variable is a non-normally distributed continuous variable, is there a statistically significant difference in mean total charge for patients with AIS, a history of AIS, excuse me. So we have not determined if the total charge variable is or is not normally distributed. So you'll go back to what you did in question 1 and question number 2 to determine if total charge is or is not normally distributed. And based on that information, you will either run another Mann-Whitney-U if the total charge is non-normally distributed. If in fact total charge in your data set is normally distributed, you will not run anything in this week's scenario, and on the Blackboard answer sheet, there will be an option that says total charge is normally distributed, therefore I did not run a test, or something to that effect. Okay. Next question, number 7, true or false? More men in this data set were discharged to a skilled nursing facility than women. So what we're going to do here is run a crosstab table. So that is in Analyze and Descriptive Statistics and crosstabs. And as we've seen before, crosstabs allow us to look at different dimensions of data and striate, either continuous variables by categorical variables, give us frequencies of categorical variables separated by categorical variables. The crosstab tables are very, very handy and are a very useful tool in your toolbox here. So we are interested in the patient gender. So I'm going to go ahead and move that over to my rows. And my column in this situation is going to be as if the patient is discharged to a skilled nursing facility. And that will be it to answer question number 7. So we'll go ahead and click OK. And true or false, more men in this data set were discharged to a SNF than women. So we can see here, patient discharged to a skilled nursing facility, yes. All right, so we have the outcome of our crosstab table here. So again, true or false, more men than women. In this data set were discharged to a SNF than women. So I'm going to go ahead and look here. Patient discharged to a SNF is yes. And I can see that I have 2,706 patients who were male that were discharged to a SNF and 3,350 female patients that were discharged to a SNF in my data set. So I'm going to say false. More women than men in my data set were discharged to a skilled nursing facility. Period. Okay. Question number 8. Question number 8 is just wants you to add a percentage calculation to this table. And in the way that I have it set up here, I have patient, sex, or gender in the rows. So what I'm going to do is run another crosstab table, but this time in my cells menu, I'm going to go and add row percentages because I am interested in the percentage of female patients who were discharged to a SNF. Okay, so we'll add that and click OK. And now I can see here that I had, again, 3,350 females that were discharged to a SNF, which comes out to 20.9% of female patients were discharged to a skilled nursing facility. Excellent. So moving on here, question number 9. Is there a statistically significant difference between the patient's gender and if they receive TPA en route to the hospital? So question number 9 and question number 10 are fairly one and the same, and this is one of our new statistical tests this week, is the Pearson chi-square test. Let's flip over to here. So the Pearson chi-square test is used to see if there is a significant difference between the frequency of two categorical variables. And as we have just done in this here, we are seeing that we have two categorical variables. And what we are going to do is run a third crosstab table here. I'm going to go ahead and click reset. and add in the patient's gender and TPA. So again, we'll add gender and TPA administration and add that to my column here. And to enable the Pearson chi-square test, you'll click on the statistics option and click on chi-square. And when you click OK to run your crosstab table for patient sex by TPA administration, you'll see that there were 7,037 female patients and 6,848 male patients who did in fact receive TPA en route to the hospital. So what the Pearson chi-square test does is test to see if the difference between these two values here is statistically significant at the alpha value of 0.05. So we will look down here to see that my Pearson chi-square has a significance value of 0.000, which would in fact mean that that there is a statistically significant difference between patient sex and if they received TPA en route to the hospital. Question number 10 is asking a very similar question, so I'm not going to cover it again, but it is just asking you to see if there is a significant difference between receiving TPA en route to the hospital and if the patient died during their hospitalization. So again, you would run another crosstab with your Pearson chi-square statistical test enabled. All right, so that covers the stroke assignment that we have this week. If anyone has any questions, please, of course, feel free and send me an email. I've received a couple of questions thus far. I am getting back to them, and I'm working through some grading for our course as well. And I'm hoping over this weekend that I will have plenty of time to catch up on everything that I have to for the course, and I'll get everything up to date for you guys. So again, any questions, please feel free and let me know. Shoot me an email. Other than that, I hope everyone has a great week, and we will talk soon.